Okay guys, so in today's video we are looking at year 6 4 operations with numbers, okay, and it's from the White Rose Maths scheme of work or scheme of learning, okay. So this is predominantly aimed at year 6 pupils, okay, for the end of the academic year, but it's also appropriate for year 7, year 8, even year 5 and potentially even year 9 students as well, okay, as well as potential revision for GCSE students, okay, for the foundation tier. Okay, we're going to start with question number 1. Feel free, guys, to obviously pause the video, have a go at the questions, and then come back and press play. But if this is completely new to you, then please do take some notes on your notepad for today's video, okay, and put today's title of 4 operations, okay, and it's from the White Rose Maths scheme of work. Question number 1, circle all the square numbers. Well, a square number is made by multiplying a number by itself once, okay, so what I mean is 1 times 1 equals 1. So the answer is equal to a square number. So 1 is a square number. 2 is not a square number because I can't think of 2 integers, so 2 whole numbers that multiply to give me 2. So that's not a square number. 10 is not a square number. 49 is a square number because it's made by doing 7 times 7 or 7 squared. And 144 is equal to 12 times 12 or 12 squared. So 144 is indeed a square number. This is question number 2. Tick the cards that are common factors of 12 and 18. So a common factor means a number that goes into it without any remainder. So 6 goes into both 12 and 18. So that is a common factor. 9 is common to 18, but it's not common to 12. Okay, so that one's going to be out. 36 is actually a multiple of 12 and 18, but not a factor. Okay, a factor has to equal the number or less. Okay, so you can never have a factor bigger than that number, if that makes sense. Okay, that ends up being what we call a multiple rather than a factor. 2 is a factor of 12 and 18. 4 is a factor of 12 but not 18, so that one's going to be out. Question number 3. Use the fact that 12 divided by 4 is equal to 3 to complete the missing numbers. 120 divided by 4, well, that's going to be 10 times bigger, so your answer will be 10 times bigger. So the answer will be 30. 124 divided by 4, well, that's 4 more than 120, so I'm just going to add 1 to this, so I get 31. Okay, and you can check here by using the bus stop method if you're unsure at any stage. Something divided by 4 equals 0.3. Well, if I times both sides by 4, okay, 0.3 times 4, so think of it as 3 times 4, and then you slot the decimal point in. 3 times 4 is 12, so the answer will be 10 times less than 12, so it'll be 1.2. So your answer would be 1.2, guys. Okay, question number 4. Okay, complete the prime factor tree. Okay, so 24 decomposes to 2 times 12. Okay, 12 decomposes to 3 times 4, and 4 decomposes to 2 times 2. So, if you're interested, guys, these are all my prime factors. Okay, so these are all the prime numbers that multiply to make 24. So, if you're interested on how to write it, you'd say that 24 is equal to 2 times 2 times 2 times 3, or I can write it as 2 to the power of 3 times 3, okay, because 2 times 2 times 2 can be written as an index, 2 to the power of 3, okay, so it's 2 times 2 times 2, okay, and then times a 3, so I'll write it out in full, just for those of you that are not quite sure what the index power means. So 24 is made up by timesing 3 2's together and then 1 3, okay. So 24 is made up by doing 2 times 2 times 2 times 3, and these are what I call the prime numbers, okay, or the prime factors that multiply to give me the number 24, okay, hence the word prime factor decomposition, okay. So this is what I call the product of prime factors. Okay. Question number 5, which two calculations give the same answer? Well, here I'm going to make sure that I'm using BidMass. So I do 4 times 7 first, which is going to be 28. 6 plus 28 is going to be 34. This next one, I do what's inside the bracket first, using BidMass or BODMass. 6 plus 4 is 10, times 7 is 70. The next part, okay, 4 times 7 is equal to 28. 6 plus 28 is 34. So which two calculations give the same answer? It's A and C, guys. Okay, question number 6. Tick the card that has the greatest value. 10 squared means 10 to the power of 2, so it means 10 times 10. So 10 times 10 is indeed 100, guys. So 10 times 10 is 100. Okay, 3 to the power of 3 just means 3 times 3 times 3. Okay, so this is what I call my power or my exponent. So all I'm doing is just timesing this base number however many times the power tells me to do it. Okay, if that makes sense. So that equals 27. Okay, so that's clearly not the biggest. Okay, and then 5 cubed, or 5 to the power of 3, okay, is 5 times 5 times 5, which is 125. Okay, and again, this comes down to times table practice. So if you're happy with the times tables, okay, making sure that you know how to multiply, okay, these together. Okay, if you're not sure actually, then I don't mind you to the side, guys, okay, or on your blank bit of paper, just doing like a long multiplication, okay, at any stage. That's also fine, okay, or any bus stop method when we're doing division, okay, that's also fine. I always encourage all of my students to show full workings where possible, okay. Anyway, back to this question. So tick the answer that has the greatest value. So it's 5 to the power of 3. Okay. Question number 7. Dora thinks of a positive whole number. She says it is an odd number less than 30. It is one more than a multiple of 11. Is her number prime? Well, multiples of 11 will be 11, okay, 22, and 33. Obviously, I can't go any further because the number has to be smaller than 30. So that obviously cancels that one out straight away, okay? It's one more than a multiple of 11. And it's an odd number. So 1 more than 11 is going to be 12. 1 more than 22 is going to be 23. Obviously, this one doesn't actually matter. But obviously, yeah, it'd be 34. But again, I'm ignoring that because it's an odd number less than 30. Okay. So I ignore those numbers. Okay, so her number will be 23 because 12 is not odd, 12 is even, but 23 is. Okay, now 23 is indeed a prime number because it only has 2 factors. Okay, so yes, okay, because 23, okay, has only 2 factors. Okay, 1 and 23. And that's the definition of a prime number. Okay, it has only 2 factors. Okay, 1 in itself. Okay. Okay, just to be clear, guys, 1 is not actually a prime number. So the first prime number is actually 2, and 2 is the only even prime number. Okay, a prime number is a number that has 2 factors. Okay, 1 in itself. Okay, itself obviously can't equal 1, hence why 1 is not prime. Okay, so 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, yeah, 17 is prime, and 19 is prime, okay, and 23 is also prime. Okay, so at this stage, it's knowing, yeah, your times tables, okay, up to 100 for you to be able to deduce whether a number is prime or not. Okay, question number 8, complete the table by putting the labels in the correct places. So A is a square number, B is not a square number, C is a multiple of 6 and not a multiple of 6, okay. So 36 and 144. Now they're actually square numbers, as are these. So A would go here. Okay. here would be like a multiple of 6, so C would go there and D would go there because they are not multiples of, sorry, they are not square numbers, sorry. Okay, so none of these numbers are square numbers. Okay, question number 9, work out 89 squared, so I do 89 times 89. Okay, now I don't mind at this stage, guys, and I know I'm gonna sound a bit like hypocritical here. I don't mind you using your calculator to work this out because that's obviously quite a big number. Okay, but doing work to the side here. Okay, we're gonna do 89 times 89. Okay, so 9 nines are 81, so 1 carry the 8. Okay, 9 times 8 is 72, plus the 8 is going to be 80, so 80. I'm going to put a placeholder there. 8 times 9 is 72, so 2 carry the 7. 8 8s are 64, plus the 7 is going to be 71. Sorry, guys, I think my mind just went blank there. Sorry, I was trying to think of the answer. So 71. 1 plus 0 is 1. 0 plus 2 is 2. And 8 plus 1 is 9. And then you've got that 7 there. So the answer is 7,921. Okay, but again, I'm not expecting you guys to obviously know that from the top of your heads, because not even I know that, okay, and I don't mind if a calculator was used for this question, okay, but as we progress later throughout our our school time and our school career, then this would probably appear on like a typical non-calculator paper on a GCSE style exam, okay, if you're interested. Okay, but at this stage I don't mind us using a calculator. Okay, question number 10. Harry uses these digits. He makes a 3-digit number and a 1-digit number. He multiplies them together. His answer is odd. What could the number be? Well, if I look here, okay, I don't want to times by an even number, because if I times by an even number, then I'm going to get a even number. However, what I can do is I can times by 7, let's say. Okay, I can put a 5 there. Okay, and then I can put a 8 and a 4. And the reason why I know this, guys, it requires actually like a bit of actually practice, is because I know that the end digit 5 times 7, so the answer is going to end in a 5. Okay, that obviously makes it odd. Okay, so it comes down to like a bit of like intuition and a bit of like knowledge on how to deal with like numbers in this way and arrange numbers. The reason why I know this and I'll say this again actually just to be explicitly clear, is because I know that if I times 5 by 7, the answer, so the number will end in a 5, which means my answer will also end in a 5, which means that will make that number odd, okay, potentially. Okay, not potentially, sorry, for certain. Okay, apologies for you using my mix of words there. Okay, guys, question number 11, sorry. Alex has 3 boxes of eggs. There are 6 eggs inside each box. He takes one egg out of each box. Circle the calculation for the total number of eggs in the box. Well, he takes out 1 out of each one. So 3 times 6 is 18, but then he takes out 3, so he takes out 15. Okay, so that's how much he has left. So which answer gives us 15? Well, it's going to be this one here. 6 minus 1 is 5, times 3 is going to be 15. Okay, because, so I got 6 times 3, guys, which is going to be 18. Okay, but then he takes out an egg out of each box, and there are 3 boxes, so he takes away 3. 18 take away 3 gives me 15. Okay, for that one. Question number 12, guys. Work out the missing numbers. 2 times 3 plus 4 times something equals 70. So again, using BIDMAS, 2 times 3 is 6. 6 plus 4 times something. Well, 70 take away 6 is going to be 64. Okay, and then divide that by 4, and that will tell me what the missing box is. So missing box falls into 6, go once with 2 left over. Falls into 24, goes 6 times. So the answer is 16. Okay, next part. Okay, so again, being very careful here. So I do what's inside the bracket first. So that's going to be 2 times 7, which is going to be 14. Okay, now 14 times 5 equals 70. Okay, so the missing number in the box is going to equal 5. 2 times 7 times 5 is indeed 70. Okay, right guys, that takes us to the end of today's video, looking at 4 operations involving numbers for year 6 maths. So please do go ahead and get the idea and let me know in the comments on how confident you feel with 4 operations after watching today's video. Okay, and let me know how you got on here with the questions that you tried independently. Okay, but hopefully you feel a bit more confident now with how to look at numbers, okay, and the 4 operations involving numbers. Okay, right guys, this final section here is looking at true or false here from the White Rose Maths here, and it's looking at the addition law of indices for this question. So 5 squared times 5 to the power of 4 is equivalent to 5 to the power of 8. Is this true or false? Well, this is actually false because, okay, when I multiply with the same base, I add the powers. So I do 5 to the 2 plus 4. Now 2 plus 4 gives us 6, so it's 5 to the power of 6. Okay, so our answer should have been that 5 squared times 5 to the power of 4 is equivalent, i.e. the same as 5 to the power of 6. Okay, you never multiply the powers, you always add them, okay, when you're multiplying with like the same base. Okay, hence the answer here, guys, okay, for that one. Okay, so yeah, it's false, guys. Okay, next part, true or false, simplifying algebraic expressions by dividing indices. So is this true or false? Well, 24a divided by 8a, so let's just write this out, guys, as a fraction to make it a bit easier. Okay, so I can cancel the a's. Okay, I can just cancel the a's, so that's going to go to just 1. 24 divided by 8 is equal to 3. So the final answer should be 3 times 1, which is going to be 3, divided by 1 times 1, which is going to be 1. So the answer is just 3. Hence, this is incorrect. So this is actually false, guys. Okay, a divided by a, guys, just goes to the number 1. Okay, a divided by a just simplifies to the number 1. Okay, anything divided by itself is always equal to 1. Okay, and you can check here because 3a times 8a actually gives us 24a squared and not 24a. So this is not equivalent to 3a. This is equivalent, okay, to the number 3. Okay, so 24a divided by 8a, that's equivalent to the number 3, guys. Okay, so this next one, true or false, okay, I'm multiplying terms together. So 9 times 7 is 63, and p times q is written as PQ in algebra, so PQ. So this indeed is true. So this is true, guys. Okay, and it's simplifying algebraic expressions by multiplying indices together. Okay, and again, it's from the White Rose Maths website. This last one, true or false, adding and subtracting expressions with indices, so collecting like terms here. So is true or false, guys, is 7k squared plus 3k cubed plus 4k squared, is that equivalent to 3k cubed plus 11k squared? Well, collecting like terms on my left hand side of my expression, 7k squared plus 4k squared, so grouping them together, I get 11k squared, so I get 3k cubed plus 11k squared. So that indeed proves that that is true, guys. So that is true. Okay. That is true. By collecting like terms on my left hand side, so collecting all my k squareds together, okay, and my k cubes, okay, separately, okay, I get 3k cubed plus 11k squared. Okay, so that is indeed true, guys. That is correct. Right, guys, that's the end of today's video. Okay, looking at some year 6 maths and also some true or false for GCSE level maths. Okay, if you found this useful, please like, please comment, please share, and please subscribe. Okay, and I will see you all inside the next video. Okay, bye for now.